this example, we are dealing with a parallel series. We have R1 and R2 is 3 ohm and 4 ohm, and the voltage is 12 volts. So I need to find out the RT first. In parallel circuits, we can find out the total resistance or equivalent resistance using this formula, which is going to be 1 over RT equals to 1 over 3 plus 1 over 4. That's going to be 12. 4 plus 3, 7 over 12. So RT will be 12 over 7 when you flip it. So 12 divided by 7 is 1.7, roughly. 1.7 ohm. Or let's keep it 1.71. Then we need to find out I1 and I2, V1 and V2. So for total, I will be V divided by RT. So it's 12 divided by 1.71. So we have 12 divided by 1.71. That's going to be 7 amp. So 7 amp is going this way, and it's going to be distributed between these two. So we're going to have I1 and I2, which are two different currents. However, voltage is going to be the same here and here. And both of them is going to be equal to the total volt, which is 12. So I'm going to say V1 equals to 12, V2 equals to 12 volts as well. So I'm going to say I1 is V1 over R1, which is 12 divided by 3, which is 4. And the other one is going to be I2 V1 divided by V2. Doesn't matter because both of them are the same. Divided by R2, that's 12 divided by 4. It's going to be 3 amp. 3 amp and 4 amp, as you see here, it's going to give you 7 amp. So as you see here, this is going to go 4 amp in here, and here we're going to have 3 amp. So the one that has, the branch that has less resistance is going to have more current. The one that has more resistance has less electric current. Now let's find out P1 and P2. P1 equals to I1 V1. P2 equals to I2 V2. I1 is 4, V1 is 12, I2 is 3, V2 is 12. 4 times 12, 48 volt. 3 times 12, 36 volt. Here. So in total it's going to be 48 plus 36. It's going to be 84 watts. So that's going to be the power in this electric circuit.